Okay.
Hi, I'm Daniel. I'm an exercise enthusiast, and for the purpose of this video, the first student has already happened. Let me introduce you to my brother, Mark.
Hi, I'm
Mark,
Mark.
yeah, he's Mark. He is an engineer, and I'm going to let Mark introduce himself and tell us what your background since graduating from college. Just real quick.
Okay, well, I graduated University of Georgia in 1993 with an agricultural engineering degree, and since then I've been developing products for 20, 30 years. And I started with like an engineering consultant company, a small company in Atlanta,
Remember
and
CAD CAM?
CAD/CAM. That's
Hmm.
right, and we did a lot of assorted projects, a lot of different disciplines, some architectural related, some landscaping related, some machine design related. And it's a good place to cut my teeth to get all kinds of various degrees of discipline that would help point me in a direction of interest. I could have designed buildings, I could have designed dams, I could have designed electrical systems. I had my hands on all of that, but it was product design especially um, where my interests were headed, and that's sort of where my path took me to where I'm right now. And so along the way, um, I went to a startup company called Protech,
I
and
remember ProTech.
yeah, Protech. I designed the entire uh, catalog of products for that company. Basically, human machine interface systems. These are just computers, basically, that are put into
Was that the
rugged.
ones, the enclosed and protected computers?
Yeah, so
Yeah.
these were meant to be placed out into factory floors, into rugged environments, into places where like Philip Morris and pharmaceutical places and food factories, things where like they wash down literally with a fire hose all the
Hmm.
equipment on the whole floor, including the computers. And some of our equipment went to areas where there were dangerous vapors, so if there were an electrical spark, it could start an explosion, and so we had to design units that were protect against that type of environment and be able to survive in there. Oil wells, all of that. So, um,
I remember one time y'all had the fire department come out and prepare because you had to blast a flamethrower or something at one to test it.
yeah, I mean, all of our products that were designed for rugged environments, you had to test. And so for the water intrusion test, we didn't have enough flow in our fire hoses in the back of the factory, so we actually had to get the fire hydrant out and put the recommended amount of flow on the seams and seals just to make sure everything was working correctly. So that's sort of where I really cut my teeth, and that's where I learned, you know, how to operate an engineering organization. How to understand what the customer needed and wanted and was willing to pay for, and convert that into products that they would want and buy and
Hmm.
use and continue. And so it also helped me learn about the data systems and the engineering CAD systems and the disciplines of designing parts and manufacturing. I was very fortunate to have access literally across the street for manufacturing. So if I designed something that morning, I could go have it made that and touch it that evening. It was really awesome. And so that company, it was a it was a startup. It was sole owner and a silent partner, and they were very risky, and that was a lot of fun, of course. And so part of that risk is that this is the early 2000s, is that they wanted to try to get into the area of point of sale kiosks or point of
Hmm.
information kiosks, and kiosks were brand new in the industry overall. This was before iPhones, before Blackberries and all that. So if you needed to buy a ticket for a basketball game, you couldn't do that on your phone back then.
Yeah, you used
The
to go up to a kiosk.
Yeah, so well, the first option was to go to the ticket office or to
Hmm.
call Ticketmaster and still collect at the will call, but we wanted to actually put the tickets closer to somebody's hand. And so since our company was involved with doing ruggedized type of workstations like that, well, we applied that to point of sale kiosks. And so that was a gear change for our company, but that really put me out um, to design things that were much, much closer to the average user versus the factory worker.
Hmm.
That really sharpened my skills for the design portion of engineering. Trying to um, add features that were, um,
So
co
kind of
co
almost like back end versus front end.
yeah, exactly. Things that were important for cognitive recognition and
Mhm.
learning and, how to use this thing with no instructions. This is something called affordance.
Mhm.
And so that really keyed me in there. Anyway, the company got a little bit risky, so I had to depart, and then I moved over to, a gaming company, and so I've been in the gaming industry since then, designing slot machines and lottery machines, and and that's even more, um, directed to customers because those are not cheap devices. They're designed with a lot of flavor, a lot of industrial design, a lot of curvature, molded plastics, cast metals,
They have to
electronics.
appeal. They
They
have
have
to
to peel,
appeal.
and they have to
Yeah.
last, and they have to be, um, serviced, and there's a lot of, details to make them work. It's not just pieces and part. It's displays and computers and electronics and wiring and controllers and sensors, but it's also like paint finishes and surface finishes and soft touches, leathers and rubbers and urethanes and gears, everything. So
Mhm.
the benefit of from what I see, and I know this is kind of an interview about engineering, is why did I select agricultural engineering as my major?
Yeah.
So
I think that would be a question. Yeah, most people would think mechanical, electrical. I think agricultural would be. Wait, what?
yeah, it's working on a farm,
Yeah,
but
yeah, yeah.
I've never applied any of my stuff to a farm. The reason I went to UGA is, of course, you went to UGA, and so I wanted to go to UGA. I didn't want to go to Georgia Tech because I didn't want to live downtown Atlanta. But so I I started at my degree as a dual degree, taking my core curriculum classes at UGA for 3 years, and I would have gone to Georgia Tech for 2 years for a mechanical engineering degree. That was my first path. And
Mhm.
then and then I saw that UGA had an agricultural engineering program, and so I was curious about it, and I went to go talk to the professors and the administrators and the dean, and just to learn more about it, and come to find out that it's a degree where you can get civil, mechanical, and electrical and controls all in one accredited degree. I'm like, "Well, why don't I just do that?" That's like that's management written all over it, and so that's benefited me. That's the degree I got, that's benefited me all throughout, and I've taken that, and so
So you don't regret that path.
oh gosh, no, I recommend it.
Okay, okay, good.
Um,
I'm
yeah,
glad that worked out. I
yeah,
I I know you had that decision. I never
mm,
know. I never knew which way you thought best for it.
yeah, and I've seen a lot of people with specialized degrees from highly technical, very accredited engineering universities that when they get into their careers, they become very limited in the activities that they do. They become a mechanical engineer and they stay a mechanical engineer and they're doing just certain things of a product, not the whole product. And so my experience has surrounded the whole of the product. So that's been a lot of fun. But anyway, during my engineering education, when I was a senior, we were required to take a design course over. We had quarters back then. We didn't have semesters. So
I remember. Yeah,
our,
I was
our
still
last
in quarters.
our last 2 quarters, we took the senior design class, and every senior was required to take it. And so there we were all required to find a sponsor or come up with our design of our own. And then I went the way of a sponsor. And so the goal is to design something that sponsor thought they might need, thought that was an interest to them, that would may involve some research that a student would be able to achieve, and create a design for a solution that would benefit them. And so every student did that. And since it was an agricultural engineering school, most of the projects were farm implements or Georgia power systems and bridges and dams and things like that. But I was interested in the human body. Back then I was doing lots of fitness just like you were. And
Let's
so
let's let's talk about
yeah.
that for just a
Yeah.
moment. Let's talk about your experience with exercise and with the hit version of and Nautilus and all that kind of version. Just a brief kind of your history of that.
Yeah, so when I was in high school, you were working at a Holiday Spree at North Lake Plaza in Tucker. And so I was interested in that as well. When you showed me the facility, and this is back then, these facilities were
This this
exceptionally glamorous.
this yeah, this was a
They were
discotheque.
they were designed as if you're walking into a Las Vegas casino.
Mhm.
It's a meat market to the hilt, chrome and lights and neon and mirrors everywhere. It's a
It
place
was.
to it's a place for everybody shows themselves.
Yeah,
You know,
yeah, it would have been like a mega version of today's Instagram.
yeah, it's the
Yeah,
Instagram of that age.
yeah,
And
yeah.
so I was fascinated by it. I was, kind of a nervous kid in high school, and that was a place for me to kind of grow out of my shell. And so fitness was just where I landed, and I loved it. And I loved the options of being able to do this type of exercise or machine assisted exercise. And then just like anybody, when they get into a gym like that, they just step into it and become fascinated one bit at a time. But
Mhm.
me being of kind of scientifically minded and curious, I was more and more curious about how and why people should exercise. And so that took my mind not just at the machine level or at the weight level or at the training program level, but at the human level, looking at, what why is a human formed the way they're formed? Why do we have skeletons? Why do we have muscles? And what do they do? And why do they do it? You know, it's when you suddenly just look around and realize, oh my gosh, we live in a gravity planet. We have to deal with this. And
And
so,
when people in space realize, oh wait, I'm not in gravity. We have to deal with this.
yeah. Oh yeah, absolutely. Yeah. That entails a whole program of thinking of
Yeah.
how to not just survive in that, but how to thrive in that. So, because of that interest, I selected um, your supervisor, Ken Hutchins, who back then ran the Super Soul Guild.
Hmm.
And what was his affiliation with MedX? I know he was in. I don't
He
remember a lot about his company.
the Super Slow Exercise Guild. It was actually his company, the Super Slow Systems.
That's
That
right.
I
Yeah.
think it was
Mhm.
the Exercise Guild was the trainers uh, exercise instruction, and
Mhm.
we're hoping to possibly bring some version or redo refresh a version of that.
Yeah.
But Super Slow Systems, I think, evolved into Renex, something around there. Well, Super Slow Systems became um, Super Slow Zone. They had an affiliation with MedX for a short time, where MedX made equipment for Super Slow Zone, and then Ken and Super Slow Zone parted, and there was Renex. But um, this was the he had just Ken had just started like making the or designing the linear abdominal machine and working
Right.
on it then.
Yeah.
And so let's talk about that time when you first after you decided um, and you came down for the first meeting with Ken. And I don't remember if I was in that. I
That
remember.
was in Altamont Springs,
Yep, at
Florida.
Dalton
Okay.
Lincoln at Lincoln Fitness Center
Yes.
when
Okay.
Ken was there.
Mhm.
Um, and you met with him the first time to go over some things. I don't remember if I remember probably I was training somebody else and you met with him separately. Tell me what you remember from that, the first meeting with him.
Yeah, it was in his studio. But there are a lot of fitness machines, and I'm not sure if he was researching or doing therapy or what, but it was just me and him in there, and he was showing me some of the things that he's did. I think he was curious about why I was there, what I was doing,
Mm-hmm.
why, how he could be involved with a student project, if he should, that kind of thing. And so he kind of, he was talking to me about you, of course, and your experience and his his background of what led him to do what he was doing at the time.
Mm-hmm.
And then we started talking about like, what's some certain exercises that he is not able to tend to because there's not sufficient equipment to do the training. And that turned into rotator cuff
Mm-hmm. I
muscles.
remember
There's a lot of surgeries. There's a lot of injuries related to the rotator cuff. and patients have limited abilities to recover from that, or even if they're bodybuilding, how to train for that. So
Mhm.
he was
So, go
explaining to me about cable pulls and
yeah.
and
But
and
before
stretch
we go into
bands.
that,
Mhm,
who
mhm.
did you or he or both of you decide on a rotator cuff, or was that a discussion, or how did that come to be? How did
I
that
honestly
part come to be?
honestly can't remember.
Yeah.
I don't think it came from me because I didn't even think about it.
It may have even come
Yeah,
from me, just out of
it
curiosity.
may have, yeah,
Yeah.
and so I was excited to take on a project to design a machine, an exercise
Mhm.
machine, whether it was for fitness training or if it's for physical therapy. It gave me the opportunity to engineer parts, to think of a product design, to think of a solution, to apply my engineering skills, and to study the human body from a mechanical point of view. And that's that's the project that I took on, and everybody else was doing again, coulter blades and plows and
Yeah,
trench packers and things
I
like that.
remember.
Here I
I
was
remember.
doing human body equipment, and so that was very exciting to me. I was kind of isolated among my other students trying to figure all this stuff out. And some people are curious about it, but like, yeah, I'm not just touching that. That's way out of my league. But it was a lot of fun for me. I was so excited to work for Ken because I knew he had a lot of notoriety,
Mhm.
and so I thought that might kind of boost my name if it ever needed to be, and maybe I would be able to take that skill to the fitness industry someday. So
Uh, Hopefully.
yeah, yeah, that could still
So
happen. So
it still could.
mhm, mhm,
So after the first meeting, kind of walk us through the process. What? Because I mean that's a year long process, right?
mhm. It's
Walk
half a year.
right.
Yeah, it's
Happy.
about
Okay.
yeah.
It was when was the first meeting? It was October or November.
Um, actually, I think about it, it was a year process. The first quarter, we were learning the techniques of design, and the last 2
Mhm.
quarters, we're doing the project.
Mhm.
Um, so it did last a school year, minus the summer. Um, so I think it was October, the beginning of winter quarter, around before the beginning or winter quarter when we had to select our project, or get the sponsor to be a sponsor.
Mhm.
And so I remember driving down there, it's 30 years ago, so there's a lot that I don't remember,
Me too.
um, but I I was basically looking at the way that we were trained as students in that first quarter for trying to understand what goals were, um, trying to gather requirements and organize them, um, es learning how to research the background of the issue or the problem, generate, basically ideation, generating concepts and things like that for possible solutions that could be um, specialized and crafted into a workable solution and
Mhm.
on and on. So I took a lot of notes and we were required to take notes. So, we had these journals back then. This is before anybody had laptops or anything like that. So everybody's
So
writing stuff.
let's go ahead and start up the notes.
Yeah.
Let's go ahead and bring those
Yeah.
up. You
This
decide what to show.
This is an example. I'm just gonna show you an example because honestly, I don't remember a lot of this. So, but I do have the PDF notes. This to me is actually kind of, um, let's see if I
There
can
we go.
control this here just a second. I can bear with me. So you see this front page design of a shoulder rotator exercise machine.
It's
No, I got this one.
toward the yeah, go up to the
Yeah,
top of
gotcha,
it.
gotcha. Here we go.
Yeah, go to the first
Design of a
page. Does it? Yeah, that's it.
yeah,
Design of the. Mhm.
shoulder rotator exercise cuff machine,
So
and these
kind of
are
walk us through the notes, what they do.
okay. Well, here we go. Now we see Ken Hutchins of Super Slow Systems. Yeah, yeah. So
What
now I
year?
remember
Well, look at the date. Look at the date
January
there.
January 13th, 1993.
Yeah.
Yep. And so this is an engineering logbook, and so we had to sign and date each one of our um, pages, and then
Mhm.
here's my sponsor's name. So each student had an engineering sponsor. This is um, what was his name? Brahm Verma. It's a professor. It's just
Oh,
a short little note about
so this, I think in today's world they call those advisors. Is that, would that be?
That's not an advisor. It's truly well, Ken was the technical customer sponsor,
Mm-hmm.
and then you had a professor sponsor, so they're kinda like 2
Okay.
sponsors.
Okay.
Yeah, it's
Got it.
sort of an advisor. But just a little short note about, Dr. Verma back then. I didn't have any classes with him, but I got to know him pretty well just here and there. During this project, he pulled me into his office. He had an office by himself.
Mm-hmm.
He told me, close the door, turn off the lights." I'm like, "Okay, what the heck is happening here?" And so he's like, "Let me show you something." He was in his desk
This is
chair.
still going in a bad direction.
He spun his chair around, turned his computer screen on, which you didn't, there were a lot of computers back then, but
Yeah.
he's
Yeah.
like, What's back then? What is this?" He said, "Let me show you something." He started typing on the computer. "This is something called the internet." And first time I ever saw the internet in my life. Back then, it was only in universities. It was something
Yeah.
that, that professors and administrators would use to communicate to each other. So he was sitting there chatting with somebody from Stanford and from Purdue, and like, wow, that seems pretty cool.
Well, yeah, we didn't even have it when I was there. There was one computer on
Mm,
campus, and
yeah.
it was the computer science that even administration didn't have really a computer yet.
Hmm.
The computer science department was still using the paper tape things.
Yeah. So, it's mostly like bulletin board information and
Yeah,
check the weather, and that was about it. There was nothing, really nothing to it, but
yeah. When you got
it's
in
just,
is when things started.
yeah, just a side little thing. So, as I go through this thing here, I'm noting benchmarks. So benchmarks are
Hmm.
things like, here's some existing solutions that other creators have done in the past for things that might be worthy of study for doing what I need to do specifically. And so this is kind of pre-research, just general knowledge of what rotator cuff does before I even know how to approach it.
So,
And
but
so,
before you go on, what I want to
mm,
emphasize, kind of to the people watching, is we're not trying to promote the rotator cuff or this rotator cuff device or anything like this.
no.
The process of this is what I want people to see. The process of a student design project coming to life, no matter what the end product is or end result is. So this is kind of what I want to talk about. The rotator cuff part, I still am. Which one of us decided? We'll find out maybe someday. But go ahead.
Yeah, and another point to note, this is from the perspective of a student.
Yes.
So, if I were to do this in a corporate job designing like real equipment, we would get a
Hmm.
little bit more detailed with this.
Yeah.
So this is sort of an academic approach, but it is stuff that actually we do carry today. So this is called a QFD chart. I can't remember what QFD stands for, quality functional deployment or something like that. Um, and it's taking a look at here's some aspects. These are aspects of things that might be important for this type of exercise.
I would say
And
probably quantitative, something quantitative.
yeah,
Huh?
quantitative functional deployment or something. Yeah,
Yeah.
that's right. Yeah, quantitative. That's right. Because here's some numbers.
Yeah.
And
Yeah.
so,
Exactly. That was
yeah,
the. Yeah. I see
yeah.
numbers.
And so here we have, um, it says engineering requirements. I don't know if these would be requirements today. Um, they're more sort of aspect or product aspects, if you will. But
Okay.
I may approach this differently these days. But here you can see the benchmarks that I from the previous page. You know,
Ah.
and I'm kind of just like weighing the importance of these aspects versus these other things that are important to the user, and kind of numerically scoring, helping me approach which features of these benchmarks might work best for a solution that I would carry forward.
Hmm.
So it's kind of a way to help the student guide themselves if they have several radical concepts to, take this good part of one, add it to the good part of the other, add it to the good part of the other, look at the deficiencies of this one to avoid, look at the deficiencies of that one to avoid, combine all those things to help you form some ideas for a workable solution. And that's really all this is doing. So, here's a planning stage. I have an objective with tasks here, research a subject. One of the things that I had to do was, there's no internet again, so I can't just Google anything. I had to go to the science library. So I went to not just the UGA science library. I went to the Georgia Tech library, and I
I
tried to
remember.
just
I remember. Yeah, I remember that.
and I
Keep
and I
going.
tried,
Yeah.
and I'm not going to show all these notes, but
Yeah.
I I I, I here's a calendar. Um, but basically what I did. Let me hold on just a second. Let's pause this.
Okay. We're pausing it.
Um, I first had to learn, what is a rotator cuff? What does
Hmm.
that even mean? It's not just muscles. It's the fascination grew as I went through this project because I had to really dig in and research human anatomy and physiology and structure and construction and development and really get an understanding of is what is this motion? Why does this motion exist? How is it formed within a body naturally? What are the important areas of it? And then beyond that is like, what is it attached to? If
Hmm.
rotator cuff is not just something that's out there in space all by itself, it's sort of dependent on other things, which are dependent on other things, which are dependent on other things. So you kind of follow those dependencies and it arrive at a total structure of a human trying to survive the world, and you really put it all together. So in doing this, I was looking a lot of cadaver photos and scientific studies um, of injuries and anatomy diagrams and stories of surgery and things like that. So I learned all about the spinal column, the the shoulder blade, the clavicle, the collarbone, and things like this, and the humerus, and all these ligaments. And so what I learned that was very fascinating to me is that the scapula, the shoulder blade, is really just nothing more but this service structure that is almost for nothing else, but to give a tie down point for muscles that are used for motion elsewhere.
Ah.
And the whole thing, your entire shoulder um, span from your spinal column out is basically a suspension bridge.
Hmm.
So you have compression components here in your collarbone that reaches out to these endpoints supported by this muscle, which
Hmm.
basically is your are your
Trapezius.
yeah, they're suspension columns that allow the span of your shoulders to be out here and to service your arms. And so the shoulder blade is serves no other purpose but to hold the muscles to allow me to do this or
Ah.
this or
Hmm.
this or this. And so,
It's an
you know,
anchor.
it's just a it's
A floating anchor.
yeah, it's just a plate out there that's just a place to put stuff basically. So I was like, wow, how did that form over the eons? And I'm glad it did because it allows us to do so many things. So I became just excited about everything else that a
Hmm.
human could do just by that bit of study. So anyway, after that research about learning what that type of system is and why it's constructed the way it is and what it allows you to do, it allowed me to figure out, okay, what is the isolation that I need to provide in a device to allow specific muscles that are attached to that scapula to be exercised. Because from my bias of learning how to exercise,
Hmm.
it was important for me to isolate a muscle group to be able to focus on it. That's an assumption, truthfully, an engineering approach. That's an assumption that I had to just assume was true to carry forward. To this day, I don't even know if it's really true. If you need to purely isolate a muscle to properly exercise it.
We
But that's
we
the approach
current
that I
yeah
did.
we currently suspect you don't,
Mhm,
and you know, uh, organize exercise plans and sequences based upon that kind of new assumption.
mhm.
But for the purposes of medical exercise, let's just say it is.
Yeah,
And
f
we so like you said, we make assumptions when
mhm,
in certain design, and you do the same thing with exercise selection, whether it is a machine, body weight, free weight, static. I make certain assumptions about how my body works in order to get that to achieve what I want. And I
yeah,
guess as an engineer, you have to say, all right, so we need. I'm going to assume we need to isolate this for this to do right.
yeah, it was a viewpoint held by Arthur Jones, a viewpoint held by Ken Hutchins,
Hmm.
a viewpoint held by, who was involved with writing the Nautilus book back then? I can't remember these guys'
Darden,
name.
Ellington Darden, yeah.
Yeah, it was his viewpoint, and it seems like a reasonable viewpoint, and so, me being the student, it was important for us to take assumptions to carry forward, and so I carried
Hmm.
that assumption. Years down the road to now, I realize, this is just a personal opinion of mine,
Hmm.
is that we're creatures that are constantly fighting objects in gravity,
Hmm.
and so for just some primitive guess, I personally think it's important for groups of muscles to work together because you're trying to exercise a system to allow that system to survive the world.
Yeah,
And you're living with a system.
exactly,
So,
exactly. More and more exercise sequences are now
mhm,
more compound,
mhm,
um, more groups of muscles rather than isolated muscles. And in static exercise, we're not just not isolating the muscle, we're not even isolating the movement. I
mhm,
mean, we're stopping the movement. And so, uh, one of the things I want to do with some of the things you're talking about is in the future have the tools where we can explore those points,
mhm,
where we can have, okay, here's this device, let's actually test them,
mhm,
how, according to our specifications, according to our standards,
mhm,
um, and really look closely, more so, our type of exercise, we've looked more closely at the single repetition than pretty much everybody else has. And we want to do that with all parts of exercise. So having devices where we can do that, we just there we would like to have more of these devices. So that's kind of what I'm trying to work on
sure,
here.
sure.
Um,
So,
and like you said, to have each engineer, each designer is going to have certain assumptions, and some designs are going to be wrong assumptions. We just kind of have to accept that.
yeah, the universe of continuous improvement and development
Yes,
is
yes.
is is exploration into the unknown
Hmm.
to some degree. There's a lot about biology and physiology that is unknown. It's why it's a constant field of study,
Yes,
right? But,
and why have now a tendency to assume, first of all, I'm probably going to start off wrong, and I'm
yeah, and
probably
that's
going to
fine.
end up wrong. Yeah,
That's fine. All steps are necessary to learn.
exactly.
So,
The only goal we need to have is to be a little less wrong than the people who came before us.
yeah, or to demonstrate the things that
Hmm.
are right. Um,
Yeah, yeah, exactly.
so when I approached the eventual design that I was gonna come with, I did it from an approach where I thought about the process
Hmm.
before an illustration of any machine was created, because I didn't wanna do it blindly. So I thought, "What ought a human do in preparation to exercise this particular muscle?" So I took it from the point of view of isolation. So that meant I had to relax their body weight, which means sit them in a chair.
Hmm.
And so I thought, well, to sit in a chair properly, you have your glutes attached to a hip bone, attached to a femur. So now I'm far away from the
Rotator cuff.
yeah. So I'm thinking about, well, how is a butt designed and what makes it comfortable? And that's what humans have been doing for eons, how to design a chair. So I thought, well, it needs to be, you got rotator cuffs on both sides of your body. So whatever I do, I probably need to center the, the human in a chair, which lent to the ideation of chairs that were designed to center a human. Um, so just taking that bit of the process in mind to forward to ideations, I thought of chairs that sort of had wedges on both sides. They're padded,
Hmm.
but they're also wedged on your left and right. And this is how race car seats are designed today. That forced you into the center of the chair, with which the rest of the structure of the machine was designed around. You
Oh,
couldn't.
okay. So
Yeah,
seat first. So
yeah. I
seat.
mean,
Yeah.
if you're here, a machine wouldn't work. If you're
Yep.
here, a machine wouldn't work. If you're going to exercise both rotator cuffs at the same time, if I were to design a machine that were to design both of them. And so I decided to design a machine that would exercise both, not just a left or a right, to see if
Hmm.
I could get that to work. The reason I did that is because I thought it was important, since the bridge structure here is a two-sided bridge. I didn't want isolation of one to cause a discomfort and unknown imbalance of the other.
This is an important point. This is
Mhm.
because this is something that Ken has and in the last 22, 3 years,
Mm.
been he's uh, not I guess come out against very much wants to make sure bilateral movements occur and
Yeah,
to avoid as practically as possible unilateral movements.
yeah.
Um,
So it was an
yeah.
assumption, I thought that was important.
Hmm.
I didn't want to do too much exploration and cause injury because one side was being focused and not the other. So even if somebody were to be rehabbing a left shoulder, exercising or even just simply moving the right shoulder would be of benefit for just physiological balance.
Yeah.
So 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 part of my process was that the human would approach a a creation, be centered into it in a seated position, and then rest back to let the rest of the gravity disappear from their frame, and then to position the basically the back of their neck, which is sort of the what I call the fiducial. A fiducial is a center reference point.
Okay.
Um,
It's kind of like fiduciary.
well, you can think of fiduciary. Um, some good examples of fiducials are, um, I like to call them the Jesus bolt. So if you think
Or
of your
how about Keystone? How about Keystone? Would a Keystone be?
Keystone's a great example of a fiducial.
Okay.
But if it's sort of like, if this one thing's off, everything's off.
Okay.
That's kind of what it means.
Got it.
If you think of a trailer hitch carrying a camper,
Hmm.
if the pin pulls out of that hitch, it's gone.
Yeah. Yeah.
That that's a fiducial point. And
Okay.
so when I was researching the
So
the si
the pin is the fiducial point,
the
not
the
the
pin
hitch.
the pin
Okay,
is the
got it.
fiducial.
Yeah.
Yeah, yeah. And so I call that a Jesus bolt. If that
Yeah.
bolt disappears, then, oh, Jesus,
Oh
we're dead.
Jesus.
Yeah. So, in the structural assumption of setting up the exercise, I studied the physiology, and it arrived at a decision that this particular vertebrae point behind your neck, you can kind of feel it if you reach back. It's sort of humpy.
Hmm.
Is an important reference point that all of this hangs upon. Can you imagine
Hmm.
that?
Hmm.
And so if I could get it to where I could center this and put it onto a target, then I could line up everything else around this complicated mechanism. That's that's a suspension piece and an arm and a
Hmm.
shoulder and a group of muscles. So that was the strong challenge and difficulty of designing this machine, was setting up that alignment. And so back to my process, I actually had little block diagrams of the process.
Hmm.
Person approaches machine, on and on and on. Sits down, lines himself up. The second one was to actually get back out of the chair, or check your position, um, get out of the chair, and then rearrange the position of the chair according to their human form, because everybody's of different sizes.
Yeah. Oh,
And
yeah. Those block diagrams are in the notes. Yeah.
yeah, yeah. I, I'll look for them.
Okay, that's all right.
Maybe it's something you can show later.
Yeah.
Um, and it's an important approach to do it that way before you think of the product, so you can help understand what the needs of the product should be before you design it.
Hmm.
So, one of the things that I considered in this whole project was the fact that humans were of various sizes. So then I had to go back and research, how do I understand what these sizes are and supposed to be. So I went to NASA documents and Air Force documents. You can get a lot of information for that, because all the seats that are designed for these high performance critical machines are to hold humans in positions during dangerous moments of flight. So there's a lot of research about,
Max
what it,
Q.
yeah, what a natural position of a human body is floating in 0 G.
Hmm.
It's almost like a fetal position, um, where all
Yeah.
muscles just kind of relax to this comfortable state. And so my goal was to try to get the body close to that state as possible, but also to accommodate um, short women, tall men. So I had to think, what's the nomenclature around this? So I learned that there are um, size standards, human factor standards for
Hmm.
that people design products for, and so I tried to research that and dive in and figure out what I could grab out of it. There are American standards, there are Japanese standards, there are European standards, and they're all different. So I targeted American standards because I had to start somewhere. And I heard, there are 5 percentile, what are called percentiles. There are females in America that are of all sizes, and there are males of all sizes. And so they kind of group these into the extremes: 5 percentile, 95 percentile, and 50 percentile, kind of the small, medium, and large.
Hmm.
And then so there's some figures out there in standard documents showing sizes of point to point body dimensions that you could reference from to design anything around it. And I actually still use that today. And so I actually have today I use SolidWorks 3D CAD modeling, and we actually have human CAD mannequins that we can use to kind of position themselves into an environment that we're trying to study, and we can design around those positions. Very, very important, especially for exercise machinery. So I applied that. So to do that, I had to make a seat adjustable, both in width and in height. And it wasn't just as simple as making it go vertically height. I had to set up things to align to a mechanism, so there was sort of an angular adjustment to the height that
But
I don't want to describe
I
now.
want to pause you here and
Mhm.
remind the audience this was before the internet. You were
Mhm.
doing this on paper.
Yeah, this is libraries and internet.
Yeah.
No libraries,
No
no
internet.
internet, no internet. Yeah, and everybody did this. The
Yeah. It was. That's how it
yeah,
was done then.
yeah. So I mean, the key takeaway here is that humans are different,
Hmm.
and if you want to design equipment, anything for them, shoes, clothes, is that you have to be cognizant of those differences if you want to accommodate everybody. And so, if I were to take this to product, I would have to make decisions of, do we make this thing universally adjustable, or do we make 2 or 3 machines of different sizes? If I were to sell to the Chinese market, would I scale down everything appropriate to that population? How do you facilitate the world with this?
Hmm.
And so that's an important thing for an engineer to study, is this accommodation of as many, just to make it, you know usable by anybody.
And that would be an important with a patient population too,
Absolutely.
because
Yeah.
like some people are not going to be ambulatory. Is that
Yeah.
the correct word? I think ambulation. I forget.
Yeah.
Well, they can't walk until they'll need assistance, and the machine can't prevent
Mhm.
assistance from so things like that.
Yeah.
Um,
So
yeah, keep going. Go ahead.
I would be terribly sad for designing a great solution for somebody who couldn't fit in it. So,
Yeah,
yeah,
yeah.
I put some focus into that. I probably didn't put as much focus as it needed, but I started I just I tr the seat was where I could start. So the rest of the structure was the complexity, and maybe I can go back to the notes here and just kind of
Okay.
show some
Yeah.
views. And while I look for these, um, the the thing that I was trying to solve was where the where the arm should be to exercise the rotator cuff muscles. The purpose of rotator cuff muscles is to do this and this to rotate the humerus.
Hmm.
Your arms could be anywhere.
Internal and external
Yeah,
rotation. Yeah.
from your
Of the
shoulder,
of the
from your
humerus. Yeah.
shoulder. It could be from here,
Hmm.
from here. It's all doing it in all directions. That's why
Even straight down.
that's why that scapula is just so complex back there. It's so full of pinpoint muscles that wrap all the way around this. I had to study torques and forces and all of that. Um, because when you get the mechanism complete, you have to assign weight stacks to it. Or that's what I did. What's the right amount of weight stacks? Do you do 20 pounds? Do you do 10 pounds, 5 pounds, 2 pounds? What's the digits that are important to do it, or should I have done it with stretch bands or whatever? But the important thing was to actually get the arms. Let me get in a good position. Get the arms in an appropriate orientation and position to do the best exercise possible for exercising the muscle and recovering the muscle. So
Yeah.
I found this balance that was sort of in between here and here and here and there, which
Hmm.
was about right there. It was about 45 degrees this way and 45 degrees this way
Hmm.
was sort of this happy balance. And even that was an assumption.
Yeah. Yeah.
That's
I get
something
it.
honestly, to carry forward that to a product, I would prototype something at varying different positions and see what was optimal. But my assumption was that was a comfortable, natural, isolating position to exercise this motion that is also used here and here and here and here.
Hmm.
So theoretically, I could have designed a machine to also do it here, but I just picked here. So I'm going to go back and see if I can find. Bear with me for a second.
While you're looking for that, I want to talk a little bit about what he's talking about in terms of the um, scapular motion. A lot of people are familiar with when you're lining up on pullover machine. Your shoulders do this, all kind of stuff, and so you have like what I call a drunken axis of rotation,
Mhm.
and you have to accommodate for literally a drunken axis of rotation for these type of exercises.
Okay,
Go ahead.
I don't think I'm showing the right. Let me
This
go.
is volume two. You're showing volume two, page one, or not page
uh,
one, volume two, one, page
Gosh.
one.
All right, let me go find the right thing here. Sorry for being disheveled here.
Hey,
Okay.
we're off the cuff. Here we go.
All right. So
Ah,
here,
volume
this is
two, page one. Okay, okay, I see, I see. Go ahead.
this is kind of an illustration, just a very crude early illustration. We used AutoCAD back then, and
Hmm.
I'm not designing parts. I'm just designing concepts here. This shows a seated human. You can see there's some wedge design of the seat to keep their torso centered, and
Hmm.
they're also isolated in the center. But I have the back of their neck point sort of positioned here along this transmission piece here, and
Ah,
I call the movement rotating parts of exercise machinery transmission because that's basically what they are. They're
okay.
shafts. They're they're held by pulleys and cams and belts and chains. They're and bearings.
Transmission.
It's all transmission. And so the idea was to be able to transmit force to um, torquing pulleys that would apply torque to this shaft that would be translated in the axis line of the arms of the of the humerus bone. So that was my challenge, was how do I design equipment that is basically in line with the humerus?
Hmm.
Very difficult.
Yeah,
Um,
yeah, it was.
because as you can see here, and I know it may be challenging to see, I have a shaft here going up to this frame, which jogs out, goes along, and then behind the seat comes back in, and then lines back up the shaft. That allows you to put your humerus into that area that's in line with the axis of the shaft, and it can rotate concentric to the shaft against these force pads and allow that rotation.
Hmm.
So much of the difficulty of this project was figuring out how to do that comfortably, do that with size adjustment, and do that with affordance. And what I mean by affordance is, um, what affordance is when when a user or an observer approaches a creation that's designed to be usable, if they can look at the creation just by its own form and understand how to use it without instruction, it has very high affordance.
Hmm.
So if they look at a creation and they're completely confused by it and they don't know what to do, it has very low affordance, or meaning it has to have a lot of manuals, a lot of learning, a lot of instruction.
So
So,
like like a medic's lumbar extension would have a low affordance.
yeah, if you walk
Okay.
into if you walk into a pilot cockpit, it's got very, very low affordance. You
Even more so for the space shuttle.
Yeah, and so but if you look at your remote control for your TV, it's got a little bit higher affordance.
Got it.
If you got your iPhone, it's very high affordance. Your mouse is extremely high affordance. So it's important to me for these types of machines that are specially used by the general public to
Mhm.
have as much high affordance as possible. So I was trying my best to keep that in mind in designing this. Um, and so here, this is just a nice little glimpse. This is showing sort of a representation of a humerus. Here I call it actually humerus shaft. This is a representation of your bone.
Mhm.
These would be tie down points of tendons upon that bone that are on the surface of that shaft that are causing rotation. This shows various angles and various forces. So that bone is held in place by certain muscles and ligaments, but it also is caused to move when these things are certain vectors. So this is a whole study of that. And then, okay, here we go.
So okay, that was going to be my question. This is
Yeah.
what you're doing here. Like when an artist does a study and practices drawing.
Mhm.
So this is you're doing research and studying what to do next. Is this that part?
Yeah, well, the goal here is, if you can see by this diagram,
Hmm.
here's a front view of a clavicle and all these muscle groups wrapped around a bone. This is a humerus bone in your arm,
Hmm.
and they're all basically have general what are called vectors. Vectors are um, directional points of either force or movement. And so these muscles are attached to the outside surfaces of this fixed bone, which is a ball joint up here behind the muscle. If this muscle here that I'm showing here, can you see my mouse?
Hmm. I can see
If
it.
if that muscle,
I don't know if everybody else can
yeah,
see it, but I can.
if you can see it, they can.
Okay.
If this particular muscle contracts
Hmm.
into this direction, and the same if this muscle contracts, and if that muscle contracts, because of where they're tied to around the surface of that humerus shaft, it's gonna cause that shaft to rotate about this red axis. Those are what rotator cuffs are doing. It's rotating the humerus. So this diagram is a simplification of that type of construction.
Ah,
The
you're
reason I had to
showing. Yeah.
Yeah, the reason I had to study this is because this vector down here is also meant to be tied to the outer surface of that humerus in theory, and counteract all these other vectors. So
Hmm.
one of the ideas in engineering of statics, engineers in their first year learn statics and dynamics. Statics
Yeah.
is the is the study of stability, um, under forces, under loads, and then dynamics is the study of motion involving forces and those kind of things.
Hmm.
This is a static representation, and it locked along the axis of rotation. My question in the study here is, what force do I need to apply here that is appropriate to counteract what is going on up here? Because this is where my machine is designed. My machine is designed around keeping this axis stable such that it can only rotate. The bone's not gonna swing back and forth and up and down. It's gonna stay in a
Mhm.
position and stay on that axis, and a force has to be applied here, a pad, that's what that little bottom vector is, to do the exercise.
Okay.
So my goal in the whole project was to create this force in an organized way. That's the whole project is creating that force. And so this is a whole study of everything. Um,
Not Arthur's original um, definition of exercise: organized movement against resistance. So that
yeah,
that would have been the application, or the this part of the planning of that part
yeah.
of the
And so
definition.
in saying that, what Arthur Jones said, it actually means a lot
Yeah.
because when you apply a force to a movable structure, features within that structure have to endure that. So, as you can see here, we have this clavicle, we got this collarbone, we have this humerus, and we have this ball joint up here, and we have forces against that. So, just applying force means that all these little internal things are going to happen. So, I had to study
Hmm.
all those things that were going to happen to make sure that I understood them and that I was not potentially applying damage to any of these structures by creating the exercise. So that's a lot of what's going on here. Let me go back to actually I can go further here. I honestly don't remember what all these notes are here, but I want to go through them. But here's sort of a diagram of how I'm actually trying to align the human. As you can see here, where my mouse is about where the back of their
That
neck
point, your
would be. Yep.
Jesus stone. Yeah.
But behind it here is some theoretical vanishing point where the humeruses converge upon. So if you put both of your arms out here in these positions, the axis of these humeri, what's the plural of humerus? Come out to some theoretical intersection. That is that by my measurements here, and these are approximate based on 50 percentile females or males or whatever.
Hmm.
If it were 12 inches spread between your ball joints here, this intersection would be 6 inches back here, and that was done by calculation. Um, but so my goal is like, how do I need to create this transmission? If I have a shaft on the left and a shaft on the right, and there being forces being applied to those shafts equally from one source, how should they combine? How does this transmission need to be designed behind the human
Hmm.
to apply the torques onto their shafts? And so that's what a lot of this other research was involved about. So I'm trying to see if I can find. Oh, here's some
The
information about
padding,
the
the
seat
seat
pad.
and the
Yeah,
pad. Yeah.
yeah,
Yeah. The
um,
seat pad and the back pad, and that's the brace for the back pad. And I
yeah,
remember I remember you really having a lot of difficulty trying to decide the angle of the seat. I
mhm,
remember that was a struggle for you,
yeah.
of how to put that.
Here I was actually designing pad features around the actual clavicles themselves to get them in an appropriate position, to get that
Hmm.
ball joint in a safe position, to to keep it in a stable alignment and on a stable axis without moving around so that the axis could be held into position. So that's what these seat pads for are. So here I have descriptions for each feature of a seat pad. Again, you're not just when you create an exercise, you're not just dealing with that little bit focused muscle. You're dealing with the
The whole
entire
body,
body.
entire body. Yes.
You can't take yourself apart to do this stuff. So
Nope. Even if
everything
you
has to be
relax
considered.
everything, it's your whole body is involved
Yeah,
somehow.
yeah. So here I'm trying to come up with possible concepts that I could use to adjust a seat or adjust positions of certain mechanical parts. So here I'm designing frames to hold this padding,
Hmm.
and it's all concept. All this is subject to change, and of course, all this is AutoCAD or hand illustrations. I didn't design it. There was no 3D CAD back then.
No,
It was really difficult to design because of these hard angles that I was
I
dealing
remember.
with.
Yeah.
Um, so let me come back to stop sharing that. Um,
So one of the things I would like to talk about also is in today's world. If
mhm,
you are a student today, like in a maybe 3 to 5 minute synopsis, what would you do different today? Because you go to the kid. You're a capstone judge at UGA.
yes. So, yeah,
And
let
go
me
ahead.
speak to that for a second. So,
Yeah, go ahead.
UGA has changed to a full engineering school,
Hmm.
on par with any engineering school. So, a common event that engineering schools across the country host are what are called capstone projects, and it's
Hmm.
very similar to what I did, except it's a little bit more involved. You actually get to build prototypes. You
Hmm.
it's teams of students that are
Hmm.
involved instead of just one individual student, and you have to not only design the solution, you have to be able to present it well. And actually, for my project, I had to present it to before some invited judges. It was not one that required a prototype, so it was a little bit longer key. So I do go to UGA even today, and I'm a judge for these capstone projects. That's a lot of fun. And I think that's very enlightening for the students. Actually, I'm gonna be producing a video soon of 12 key recommendations to win a capstone project. So
I'm
we'll
looking
talk
forward to that.
we'll talk about that later. But what was your
Okay.
question? What would we do differently?
What would you do differently in today's world? If you were a senior, if you were a senior engineering student
Mhm.
in the upcoming year, how would you approach this specific project differently? What would you
I
do?
th Well, I think the easy answer to that is take advantage of today's technology and information pool.
Oh yeah,
Is
yeah.
that
Well, I mean that's the obvious,
yeah,
the giveaway.
we have a lot more public access to deep information, which is I'm telling the young kids this. You live in a wonderful age
Yeah,
for
yeah.
being able to very quickly get to some very specific data
To
that
be,
is
I
th
call this. I am carrying around a portal to the information of the entire planet, almost the entire knowledge of
oh, yeah,
mankind.
on my iPad here, I have a
Yeah,
my own, my own version of a 3D CAD system called Onshape. It's a subscription service, but I can do 3D CAD, very complex geometry with motions and forces from my phone or iPad.
yeah.
It's
It's a different world.
it's a wonderful age. So, but the way I would approach it is I would actually have a team. So it's more important just than to have just one mind
Hmm.
work on a thing like this.
Two
But
eyes are better than one.
2 eyes and also just, not the same eyes. Hey, it's good to have
Yeah,
some
exactly.
it's good to have, some assorted backgrounds come to it, somebody who's come up from a different set of biases and lifestyles. They may have some just wild ideas that you've not even considered at any level of the research or the ideation. So that's important. And but also to know, you know, make sure that your curiosity is turned on at every level. Make sure that you have the ability to interview patients probably. That's one thing I didn't do
Hmm.
in this program is I never talked to anybody that actually had rotator cuff problems or a doctor who did surgery on that. I think that's very I think that's critical. When
Hmm.
you're designing things that interface with humans, there's just so much complexity to a human that even today are unknown. And the more that you can learn about physiology, the more information you have to consider.
Mm.
And so never stop learning about human physiology. And today, I'm a runner,
Yeah,
and
yeah.
people often ask, why do you run? It doesn't benefit anything. To me, it benefits just a lot. It's allowed me um, to focus on the tiny and also focus on the vast. And what I mean by that is it running allows me to understand what my body is doing at the capillary level, at the cellular level, at the specific at the brain level, the reaction level, all these things that you don't really think about when you're running, but I dwell there a lot.
For you, running is a study.
It's a study of
It's
me. It's a
and
study
as much as it is an activity.
it's a
Yeah.
study of me, it's a study of my anatomy, a study of my cellular biology, and a study of humanity. And
Hmm.
it's also a study of the wide and vast. What I mean by that is, I've driven from here to the other side of town a million times, but when I run it, I know that there are 12 hills. I know where the rabbits live down the edge of the embankment. I know that it's a 2.5-degree incline from Dairy Queen to the stop sign. You learn about the world very quickly. So,
And I remember us also talking about one time when we were starting barefoot walking a lot.
mhm,
The information you get from the bottom of your feet in these places tells you a lot
mhm,
too. Yeah.
yeah,
Anyway, I
yep,
have I need to go to the restroom.
that's fine. I
I
understand.
I hope I want to stop here, and then I hope to have more. I want to have more of these in the future. Not like this. This is just an intro to you, to
Mhm,
your what you've done, and I have really good memories of that time. And one of the things I remember, and I know this is going to seem kind of morbid, but our grandfather passed away during that time,
yes,
and we were at the funeral home,
mhm,
and quite you were in the middle of this project, and
I remember this.
we were talking about, wonder
I
if we can
remember
use the
this.
shoulder. And I was like,
Yeah,
Mark, don't be quiet, be quiet.
yes, I
But
remember.
your engineering mind was there, and he would have
We're
loved it. He would have said, use it, take it. I
yes.
know he would have, because he was
I
an
forgot
engineer.
all about that. I
I
remember that. I
didn't.
was like, "Can we take apart his shoulder right
Yes.
quick and see what's inside, please?"
Yeah,
Well,
yeah. And I was like, he would have, had it been in his will, he would have done it. So I
yeah,
want to end on that as I know it's morbid, but for us, it would have been a
yeah.
good memory.
I would like to take this opportunity to,
Okay.
thank you for what you're doing here. I think this is very beneficial to the exercise community, and,
I hope it is.
mm,
I want to create something that is going to that people can submit something like this to, whether it's groups from a university or on their
mhm,
own, and have a database of plans or designs for really, really good exercise equipment. I mean, there's probably even going to be some bad ones, but they're
yeah,
going to be evaluated by engineers, by exercise instructors, by people, and then any company, anywhere
mhm.
can build this equipment. That's the goal.
Yeah, and a couple points, I did write a book called The Simplified Development
Yes, please.
Process. If any
I'm sorry. I
Yeah.
want you to give a minute or two about this.
Yeah, and if you go to Amazon, just look for Simplified Development by Mark Thompson, you'll find it.
Yes, yes.
And, it's an early book that I wrote. It was a book that I actually wrote for another book, but I thought it was good enough to where I wrote it for just explaining a very simplified language-based framework that you can look at the development of anything and understand it. And I think that's very
I'm
important
gonna
to
tell
read.
you the truth on this
Mhm,
real quick.
mhm,
I've read it through once,
mhm.
but I don't even have to read it through to plan things anymore. It I can open it to almost any page, and it will inspire me somehow.
Yeah, I
It
designed it
it
to be a page by page, almost like a
yeah.
bath.
Yes, yes, yes. Like I'll be stuck in a like, oh, how do I do this? And sometimes I'll just like thumb through it,
Mhm.
and I'm like, okay, oh, and it
Yeah.
starts the process again.
So it's yeah, I made it very affordable,
Yeah.
and so go ahead and buy it. It just to summarize it, it's just this string of words: could, should, must, shall, will, is, did. You'll figure it out. Um,
I'll try to post a link to it if
yeah.
when I post the video.
The other thing is I'm starting a YouTube channel. I've already started. I have I think 3 or 4 videos up, but I have many more planned called Innovate with Ease. So search on YouTube
Hmm.
for Innovate with Ease. I have an entire pod or entire videos list
Yes,
of several videos I'm gonna make to help anybody learn how to design, learn how to engineer, learn how to create, in
not just
ways that
exercise equipment, just
yeah,
in
anything,
anything.
in ways that universities do not teach. So
Yep.
this is sort of opening your mind up, opening the what happens behind the scenes of real development at a real company for real organizations in ways that users that observers of your creations will be drawn to and use and enjoy. So
I have
I'll
to
show
admit,
exactly how to do that.
I'm really excited about it. I mean,
Mhm.
when I say excited, I mean like happy parakeet level of
Yeah.
excited.
It's
You
very
know,
it's
yeah,
very deep. It all starts with the mind, and so
yes.
everything kinda starts there at the very beginning of this, so that's coming soon. Okay.
Thank you for this. I really appreciate it. I
Yeah,
really,
thank you.
really appreciate it, and I look forward to more.
Very good. Thank you.
Talk to you later. I'll let you do the cancel thing.